Let's start that in a moment.
Please front, please. Please stand. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Saint Michael the Archangel, defend us in battle. Be our safeguard against the wickedness and snares of the devil. May God rebuke him, we humbly pray. And do thou, O Prince of the heavenly host, by the power of God, cast into hell Satan and all evil spirits, who prowl about the world, seeking the ruin of souls. Amen. In the name of the Father, the Son, and of the Holy Spirit. Good afternoon, please. We're going to finish up. I'm going to give you some time to work today. Did I give you the actual assignment for the addition? Okay. Because I couldn't find the stack. Panicking. Write down the following. Write that down. By most sane standards at this point, this would look like a disaster. Well, find the sine of 32 degrees. Question. 32 degrees. Common or uncommon? Well, yeah. Uncommon, correct. It's not a multiple of 30, not a multiple of 45. By all standards, the only way we could get the sine of 32 is punch into a calculator and get a rough decimal approximation. Ditto with 13 degrees, uncommon. Now, you'd expect to plug this into a calculator, multiply them, and then plug in, multiply, add the two answers, block. You get some sort of weird decimal. It might surprise you. I want the exact answer. How in the name of all that's holy could you possibly do that? Well, my first question, other than that, okay, my second question. Does this look familiar to anybody? Let me write it in a slightly different way. Yeah.
Okay, so, like, you now feed it the 45 degrees, right?
Maybe.
So,
So, what is the formula? What is this from? It's,
oh, well, sorry.
go ahead and look it up, yeah. Is that the sine addition formula, the cosine addition formula, or the tangent?
Oh, it's this one.
Sine. And is it a plus b or a minus b? Correct. So tell me what this really should be. Sine of what?
Sine 32
Plus 13. What is that?
45.
Sine of 45 degrees. That should look familiar. Somebody tell me what that is? Off the top of your head? Yeah. It's radical 2 over 2. You're done. That's how you do this. The last page of the assignment that I gave you has a bunch of problems like this. Your job is to sniff through and find out the formula that they used, and hopefully it'll add or subtract to make the common angle. Now, I did promise you a little bit of a shortcut as far as we did 15 degrees yesterday, and the answer seems to be coming up very similar to each other. They're kind of weird. It was radical something plus or minus radical something all over 4. Does it always do that? Well, let me answer it by saying this. Here's a phrase, kind of interesting. Pseudo-common angles. Write that down. Pseudo-common angles, oops. I don't think I'm going to start. Darn it.
Oh, bless your heart.
You all are way ahead of the game tonight. Okay, for those of you listening at home, thank the wonderful people who hit the start button because I spazzed. So may their place in heaven be forever raised. Okay, phew. Okay, heart attack done. Got it. Pseudo-common angles. Does anyone happen to remember? You might have run into it in science class, or if you. It's not really Latin. This is Greek. Pseudo. Does anyone know what pseudo means? The most common way that people, it's actually a fairly handy prefix. It comes from the Greek. English uses it a lot. Pseudo means false. Pseudo means false. It's a Greek prefix that means false, gentlemen. Hold on. Well applied, y'all. Pseudo-common angles. It's going to be that kind of a day. Huh? Pseudo-common angles are something that looks common but isn't. By definition, a pseudo-common angle is any non-common multiple of 15 degrees. Any non-common multiple of 15 degrees. That's called a pseudo-common angle. Why do they call it pseudo-common? Well, common angles, there's two things we know about common angles. Number one, they come from a common trig shape. 30, 60, 90, 45, 45, 90, unit circle. And you can get exact answers for them. Like if I said the sine of 30 degrees, you don't need to grab a calculator. If I ask for the tangent of 120 degrees, you don't need a calculator. And the calculator would actually give you the wrong answer, it would approximate it, where you can give me the exact one. Pseudo-common angles are non-common angles, but we can still get the exact answer. There are other pseudo-common angles that you'll study in college. Interestingly enough, I think multiples of 12, you can get really, really weird exact answers, and so on. But you have to take calculus to learn how to do that. And it's a long story. Do that as it may. What does it look like? Sine and cosine for pseudo-common angles always look like this. Plus or minus radical 6, plus or minus radical 2 over 4. Every last one of them looks like that. You don't have to memorize two different fractions, just one, although it's a big one. But every sine and cosine of multiples of 15 that aren't common will fit this formula. And we've barely finished. Could somebody dig into the notes and tell me what was the tangent of 15 degrees? It was right at the end of yesterday. Yeah.
2 plus negative radical
2 plus negative radical 3. Turns out all the tangents of all the pseudo-common angles are going to fit that form. Plus or minus 2 plus or minus radical 3. So what does that mean? There are 4 possible answers. 2 plus radical 3, 2 minus radical 3, negative 2 plus radical 3, negative 2 minus radical 3. That kind of makes sense? So you mix and match, make the first one positive, second one positive, and then just keep mixing and matching all the possibilities. There are 4 possibilities for each one. Quick question here. Radical 3 versus 2. Which one's bigger? Yeah, 2 is bigger. Because 2 is really radical 4. It's a little bit bigger than radical 3. Radical 3 is like 1.7 something or something like that. So if you had like 2 minus radical 3, I'm just looking at the second one here. Can anybody tell me if the answer is positive or negative? It's gotta be positive. Because 2 is bigger, the positive is bigger than the negative. They fight each other, but the positive one wins by just a little bit, by like point something, 0.2, 0.3. So this is, what I will say, this is positive a little. Think that makes sense? It's a little itty bitty positive. Up here, if you have positive plus positive, I would say that's positive a lot. You may see where I'm going with this. Negative 2 plus radical 3. Sam, in your best guess, would the answer to that third one be positive or negative?
Yeah, negative.
Negative. And I would say they fight each other. This is like negative 2 and this is positive 1.7 something. So there's not going to be much left, but I'm going to say it's negative a little. How about this one? As long as you read it. Good, Sam.
Negative a lot.
Yeah, it's negative a lot. They're combining forces. Negative a lot. Why do I bring this up? Well, draw a unit circle. It doesn't have to be huge, but it should be at least an inch wide. I'm going to make mine quite a bit bigger so you can see. There are 8 places where there are pseudo-common angles. Now I'm just doing the multiples of 15 that don't land on a common angle. Does anybody think they can name them? Let me see. Courtney, give me the first 2. What's the first one probably going to be? We're doing all the multiples of 15 that don't land on a nice number. So the first one is probably what? Like, where's this? 30 is a common, actually. So right before that. The super duper easy one. 15, yeah. Count by 15s for me. I want to see which ones are common and which are not. 15? 30, stop for a second. 30 is a common or no? Common, so skip it. Next one. 45, common or no? Skip it, keep going. We're at 45. 60, common or not? Common, skip it, keep going. Ah. The first 2 pseudo-common angles are 15 and 75. Okay? And if you want a shortcut for this, you see this is 90. If you go forward or backward 15, that's usually faster than trying to add 15, 15, 15, 15, 15. This would be, I mean, what is this? Megan, take this one. Where is this? 105. Good. And give me the next one while you're at it. This is a 180, if that helps. Where's that? 165. Let me see. Yeah. Randy, take these 2. Here's a 180. So where's this? There's no multiples of 15, if that helps. Close. So 180, go up 15. Oops, a little bit small. That's 25. Yeah, there you go, 195. And then 270, go back 15.
That's
255, right? Oops, forgot to use. And Becca, what's the one under here? 285. And then this one, this is 360, that helps. So if you're going back 5. Got it. 345. Those are all the pseudo-common angles all the way around the circle. You all remember that sine is up, down, cosine is left, right? Visually speaking, let's just say cosine, going left, right? Cosine of 15 is over a lot. It's a lot positive. Does that make sense? It's positive because it's to the right and it's a lot. And then 75 is positive but only a little. There are 4 possibilities here. Radical 6 plus radical 2 over 4. Radical 6 minus radical 2 over 4. negative radical 6 plus radical 2 over 4. And negative radical 6 minus radical 2 over 4. Yeah, yeah, go for it. Just leave the door crack. So I would say this one is positive a lot. This one is positive a little. This is negative a little. This is negative a lot. Maybe I should put a really friendly face for negative. Does that kind of make sense? Can somebody tell me, just by looking at this chart, what is the cosine of 15 degrees? Don't look in your notes yesterday. Cosine, it's positive a lot. Which of these fits the bill? Go.
Radical 6 plus radical 2 or 4?
The top one. Radical 6, both of them positive. That is the cosine of 15 degrees. Spencer, sine of 255. First of all, is it positive or negative? A lot or a little? 255. If you're going sine, if you're going down. Yeah. So you're going down, cosine would be right. So which of these four, the first, second, third, or fourth, would give you negative a lot? Fourth one. The sine of 255 degrees is this thing. By the way, the sine of 285 degrees is also this thing. Does that make sense? Tangent. It's either plus or minus 2 plus or minus radical 3. So Nate, tangent of 75. First of all, is the tangent left, right, up, down, or slope? Slope. How about 75? Is that positive or negative slope? A lot or a little?
A lot.
A lot. Which one is it?
2 plus radical 3.
I'm sorry?
2 plus radical 3.
2 plus radical 3. The slope of 75 degrees, the tangent of 75 degrees, is positive 2 plus radical 3. Make sense? This is the short way to get the answers that we were doing yesterday. If you have those squirreled away somewhere, you will find that the worksheet I handed you, at least the front page, gets dramatically faster. If not, especially with the tangent ones, I don't know if you remember the tangent ones from yesterday, we slogged through like 4 different layers of simplifying. We got common denominator, then radical on the basement, and common denominator again, and then boil down, and blah, 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 blah. There all is. If it's a multiple of 15 degrees, which a lot of those are, I think all of them are. Some of them might be negative, but you'll end up in one of those spots. Good to go? I have one more topic to cover today. It won't be for tonight's homework, but for tomorrow's. So, starting a new section in your notes. What can I erase there? Let's do this. This is something called a double angle formula. This is actually, I'll show you in a minute, but for right now, any idea how on earth, believe it or not, the stuff that you know so far can build this? I'll give you a hint. What does 2a mean? There are 2 possible definitions. So you got a double angle. I want to know the sine of 2 times a, which is not just 2 times the sine of a. I wish. This is not equal to 2 times the sine of a. That would have been so nice. But unfortunately, 2 in the input and 2 in the output don't do the same thing. What is 2a? Don't work too hard, but there are 2 arithmetic definitions of 2a. Like, how do you get it? Like, here's a, here's the variable. How do you get 2a? I know of 2 ways to do that. Go, give me one. Multiply by 2. That's the most basic way. There's one other way.
Add it by another n.
What's that?
Add it by another n. A plus a.
We have a formula for that. We have the angle addition formula. It looks like this. Sine of A, cosine of A, you notice I'm using the same letter both times, plus cosine of A, sine of A. Can somebody simplify that for me? That actually does simplify a little bit. Not a huge amount, but a little bit. Maybe see it? I'll give you a hand. Cosine sine is the same as sine cosine. Anybody see it now? Katie, anything? Yep, there's a 1 here, a 1 here. 2 sine of A, cosine A. Got it. Excellent. Questions? That wasn't too bad. We're using a previous formula to get a new formula. I want to try that with cosine. The cosine of 2A. Can somebody tell me how to do that? Abby, try this one. How do you get 2A again?
You can either multiply or do the A plus A.
Right, and multiplying, which is perfectly good, doesn't do a formula for us, but the other one does. So what is cosine of A plus A? Go ahead and look it up.
It would be cosine A,
Uh-huh.
cosine B, plus or minus.
Although in this case,
Oh, sorry.
it's another A. But you're right. And then what?
Plus or minus,
Yeah, which one are we going to use?
plus.
There's plus here, and look carefully at the formula. The formula from yesterday, you probably have this, cosine of A plus or minus B equals cosine A, cosine B. What comes immediately after that? Look carefully.
No, I just wrote plus or minus.
Ah, fix this, minus plus.
Oh, right.
Okay. And then it's sine sine.
Mhm.
What does that mean? While we're at it. What does it mean to put a minus plus compared to this?
Well, it's just the opposite,
Right, it's the opposite sign. So if they're doing addition here, what should I do?
subtraction.
Subtraction. And then it's what?
Cosine A, cosine.
We'll get the cosine, but
Oh, sine A, sine A.
sine A, sine A. Good. Does that simplify? Let me see. Austin, take over.
Might it be like cosine squared A
Yep,
minus
cosine squared of A minus,
sine squared of A?
correct. We now have a formula for cosine of 2A. I should have circled the other one too. Cosine of 2A is cosine squared minus sine squared. Do not, please, I beg of you, do not confuse this with master formula number 1. It has a strong similarity. Especially if you read, cosine squared plus sine squared is equal to what? Okay. It's equal to 1. Is this equal to 1? No, it is not. Plus sign made all the difference. What's it equal to? Some weird something with it. But it's equal to cosine of 2A. Now, just for complete, utterly insane formulas. By the way, whenever I give a formula, make sure it's in your notes. You might remember that this particular chapter, I'm giving special permission for you to use the 3x5 note card on the test, because there are loads of formulas. And it's probably a little too intense to memorize them all. Yeah. Fernando. I've been thinking about that, and I think the short answer to that question is yes. Now, please do not stay up the night before with a microscope, and a scalpel, writing like 0.5 point font, saying, here's my H billion formula. It's like, It doesn't work very well. I actually did that in high school once. And I was so busy trying to find where I put the formulas that I almost ran out of time on the test. And it was totally stressful. So, if you're familiar with the formulas themselves, I would say just, the big formulas by all means, put on your card. This is probably one of them. There is a variation on this. If cosine squared of A is equal to 1 minus sine squared of A, that's from math problem number 1. Do you remember that from yesterday in the different form? It's sine squared plus cosine squared equals 1 if you subtract sine squared from both sides. Then, cosine of 2A equals, you notice it said cosine is equal to something else? That means instead of cosine, or actually, fluffernutters, I gave the wrong one. How many people are running in 10? I'm so sorry. Could you put the other one up there, please? If the sine squared of A is equal to 1 minus cosine squared. Thought it was too good to be true. The board was looking too clean. Okay. I want to replace the sine squared. There's a reason I'm doing this. It's coming up. If sine is really 1 minus cosine, sine squared is really 1 minus cosine squared, can you rewrite this? Cosine of 2A is equal to what? I'm beginning to add. Right there, help me out. This one you don't touch, it's just cosine squared. Minus what? And then sine squared is equal to what? Yeah. Simplify. What do you do with the minus in front of parentheses? Distribute. Go for it. So cosine of 2A. Plus cosine squared of A. There's one more thing you can simplify. Well, I'm going to add the opposite though. That could be handy.
So, you could,
Notice these are like terms.
oh, so you can do that?
Go for it.
Oh, I'm sorry.
No worries. It's a huge, complicated thing. You don't expect something that easy. Go ahead.
So there's 2 cosine squared A,
Plus negative 1. And for my own strange reasons, I'm actually going to use the old-fashioned minus 1. Cosine of 2A, this is another version of cosine of 2A. There are actually 3 different versions. The third version is what I would have done if I had done the goofed up version. So there are 3 different versions of cosine of 2A. I'm particularly interested, this one is the easiest to remember, cosine squared minus sine squared. This one looks kind of horrid. I was saying, why are we digging into it sounds like we're going into the weeds here. Well, this is, let me show you. At the beginning of your algebra studies ever, there's a rule in algebra. You can do anything you want as long as you do it to both sides. The limits on that are really, really extreme. You can do almost anything. Except divide by 0 on both sides. That's unhealthy. So you could, but you wouldn't survive the attempt. So don't do it. But you can do anything you want as long as you do it to both sides. You can square root both sides. You can raise both sides to the billionth power. You can take the cosine of both sides. You can take the inverse cosine of both sides. Watch this. You might think I'm making this up. You remember the difference between input and output, right? Cosine is the function itself. Is 2A input or output? Okay. Becca. Just visually, would you say 2A is input or output? Input, because it's inside. How about A here? Input. Watch what I'm about to do. Divide the input by 2 on both sides. This should strike you as strange. Should strike you as me reaching into somebody's abdomen and taking out half their spleen. It's just like, you shouldn't be able to do that. It's just like, something is just wrong with that. I just reach in and say, oh, you see this innards? Yank. I just divided it by 2. What did you do? I just divided your innards by 2. Thank you very much. Have a nice day. You'll get my bill. What's half the input? Mary Claire. Leave the cosine alone. Put cosine of what? Divided by 2, which will be cosine of A. Do that over here. 2 cosine squared of what? Yeah. Why would we care? I mean, it's a neat party trick, and it says, hey, half your spleen, gone. By the way, I don't do that in real life. That's grim. But watch what happens. Again, this is not for tonight's homework, it's for later on in the week. But let me rewrite what he had so far. Cosine of A is equal to 2 cosine squared of A over 2 minus 1. Do me a favor. I want to get this by itself. Algebra people, you need to do 3 steps to do that. Walk me through it. I want cosine of A over 2 by itself. What do you have to remove? What do you have to get rid of? Nate, what's the very first thing you have to get rid of on this side? I want to get this by itself. Yeah, how do you get rid of the 1? Add 1 both sides. So we have cosine of A plus 1 equals 2 cosine, and by the way, remember what cosine squared is? It's really the whole thing squared. It's a little easier to see. Sam, take over. What do you get rid of next?
Oh, the 2.
How?
Divide by 2.
Divide by 2, correct. So we now have cosine of A minus 1 over 2, plus 1, sorry, over 2, is equal to, right, cosine of A over 2 squared. One more step. Good.
Square root.
Square root, how many answers?
2.
2, what kind?
1 negative, 1 positive.
Correct. We're going to get, cancel, cancel, cosine of A over 2 equals plus or minus square root of cosine of A plus 1 all over 2. Circle this. This is what we call the half angle formula. You might think, well, yeah, great. Are we done yet? Well, the reason we care about this is that, let me get rid of these things. Does everybody have the double angle formula for sine cosine? Yeah. Okay. Let me show you why this is halfway interesting. Example. I want the exact value of this. The sine, sorry, actually the cosine now. Of 22.5 degrees. That, by any standard, is a non-common angle. Not only is it a non-cone angle, it's a decimate. It's even worse. Is there any possible way to do that? Normally it's just grab a calculator and get a decimal. Is there any possible way to get that without approximating? Does everyone recognize 22.5? Like, is there anything funny about that number? Where did it come from? Is that a random? Yeah. It's half of 45. We have a half angle formula. Now, I do have to caution you on one thing. Do you ever have this written down, the formula for half angle? You see the plus minus in front? That's a little deceptive. You have to pick one, whichever works. It's relatively easy, but you have to remember to do it. You can't take both. You got to pick one. But pick the one that works. I'll show you what I mean in a second. Let's try this. The cosine of 22.5 is the cosine of 45 over 2. I'm going to call this A. A is 45. Plug it in. Plus or minus, we'll have to pick one. Square root of cosine of what? Becca, take over. Cosine of what? Use this formula. Yes, of 45 degrees plus 1 all over 2. Do it. What's the cosine of 45 degrees? Anyway. I mean, off the top of that. Yeah.
Radical 2 over 2.
It's radical 2 over 2. Plus 1, all divided by 2. Now that's kind of exciting. Fractions inside fractions are not considered alike. Can anybody simplify that, please? Katie, help me out here. How do you simplify this mess? There are two possible places you could start. Yeah, you can split them up. So you could have plus or minus the square root of radical 2 over 2 divided by 2 plus, and under here, plus 1 over 2. Does this reduce? Yeah, multiply by the reciprocal. It's really times 1/2. So it looks like this. Plus or minus square root of radical 2 over 4 plus 1/2. Getting better. Courtney, take over. Is there anything we could do to simplify inside? Just think basic arithmetic. Like fraction plus fraction. Count it down there. Like what? 4. 1 over 2 is really what over 4? 2 over 4. Are these like terms? Radical 2 plus 2? No, just leave them. So it's plus or minus square root of 2 plus radical 2 over 4. I want to see if anybody can spot this. How do you square root a fraction? Negative. How do you square root 4 over 9? Yep. Do them separately. In this case, it'd be 2 over 3. Do that same thing over here. So the top you can't do much. 2 plus, and your eyes are not deceiving you. This is square root inside a square root. What's the bottom? What is that, really? Yeah, this problem is addicted to 2's. Radical 2 plus radical 2 all over 2. And question, we were supposed to pick one. How on earth? So you just pick one at random? Can anybody tell me where we are on the unit circle? Where's 22.5 degrees? What quadrant? Happening.
The first one.
First quadrant. So it's not very far into the first quadrant. It's like here. Are they talking about sine or cosine?
Cosine.
Cosine. Is cosine left, right, or up, down?
Left, right,
Is it to the left or to the right?
and the right,
To the right. So in your opinion, would that be positive answer or negative?
positive,
Positive. Guess which one you picked?
plus.
Yep. Throw away the negative. Your final answer is radical 2 plus another radical 2 all over 2. And that is the exact cosine of 22.5 degrees. You do not have to simplify that. I have tried to simplify that, by the way, and it is a nightmare, and it ultimately didn't work. That's another 2 hours of my life I'll never get back. I'll spare you. Questions? All right. Does anybody not have the worksheet yet for whatever reason? That was the sine and cosine addition formula. The rest of the hour is yours. Go ahead and start pounding away at that. The people listening at home, God bless you all. It's the same worksheet. If you don't have it, email me and I'll email you with the worksheet. Godspeed your healing. See ya.